Hello, geometry students. Mr. Zacek back and better than ever. We're starting Unit 2 here, and we're going to talk in Lesson 1 about patterns and inductive reasoning. Now, this year in geometry, primarily we're going to be using a method of reasoning called deductive reasoning, but we're going to kind of contrast it and build to there, and we're going to talk today about inductive reasoning. So, inductive reasoning is the process of observing data, recognizing patterns, and making generalizations about those patterns. This is what we do all the time. We look at things, we see how it works, and then we make some kind of, generalization about that. One example of that might be like red sky at night, sailor's delight. Red sky in morning, sailors take warning. But we observe things, we make generalizations about those patterns. So, as we look at these, look at a pattern. What are the next two terms in each sequence? So as you look at this first one, you might notice, well, these are being multiplied by 3. And then what's happening here in B is we've got a 3-sided figure, a 4-sided figure, a 1, 2, 3, 4, 5-sided figure. So it would make sense that in the next one, we'd have a 6-sided figure, and then a 7-sided figure, and then back up here in A, multiplying by 3. So those are the pattern, and then we make a generalization that goes based off of that. It's called inductive reasoning. So a conjecture is a conclusion reached using inductive reasoning. It's an educated guess, a hypothesis based on observation, experimentation, data collection, etc. So we want to look to make conjectures. So looking at the circles, what conclusions can we make about the number of regions 20 diameters form? So when you notice here, 1 diameter forms 2, 2 diameters form 4, 3 diameters, and when we say a diameter, we're referring to these lines that come across here. So you see like that's a diameter. That's a diameter. That's a diameter. So every time it looks like there's 1, 2, 3, 4, 5, 6, 3 times 2 is 6, it looks like we're doubling that. So 1 diameter, 2 regions, 2 diameters, 4 regions, 3 diameters, 6 regions. So we could make the conjecture that 20 diameters would give us 40 regions of the circle. All right, so that's inductive reasoning. Here's another example. Points A, B, and C are collinear, and B is between A and C. So the conjecture that we could make from that is AB plus BC equals AC. That's our segment addition postulate. Now I want you to point out here, the key word here is collinear. This is a little different from one of our earlier homework assignments where we couldn't make that conjecture because we didn't know that those were collinear. So in order for that to be, we need that place. So that gets into this. Not all conjectures turn out to be true, and we want to test the conjecture multiple times, and we can prove that a conjecture is false by finding a counterexample. So counterexamples are examples that show that whatever my conjecture is right. So in our, red sky at night, sailor's delight, that means the next day is going to be nice. Well, what if the next day is bad? All right, so that's a false conjecture. So here's a conjecture. All parallelograms have 2 acute angles and 2 obtuse angles. Is this conjecture true or false? If false, provide a counterexample. And the counterexample would be a rectangle. So a rectangle is a specific type of parallelogram, and those angles there are right angles. A right angle is neither an acute angle nor an obtuse angle. So therefore we say the conjecture is false because we can find a counterexample. So here's another one. If P, Q, and R are collinear, then Q is between P and R. Is this true or false? If false, provide a counterexample. Well, that's false because it doesn't say anything about Q being between P and R. It just says they're collinear. That means on the same line. So therefore, Q is not necessarily between P and R. Okay, Q could be anywhere. It could be, but it also could not be, and that counterexample means it's false. So let's try this one. If A, B, and C are collinear and B is between A and C, then B is the midpoint of AC. So is that true or false? Well, that's false. All we're given is that B is between A and C and on the same line. We don't know that it's the midpoint. We would need something else. So B, not every point in there is going to be the midpoint. So that's a false conjecture. All right, if A, B, and C are collinear and B is the midpoint of AC, then AB equals BC. Is this conjecture true or false? Okay, that's true because there's no way you can draw that or create that without that being true. And that's the definition of a midpoint, is that it divides a segment into two congruent or two equal segments. So what we're getting at here a lot of times in these examples is the importance of being very specific with our definitions. So the problems that arise with inductive reasoning, we arrive at generalizations before every possible case is examined, and reasons are not provided for why things are true. Okay, so we're just making an observation and then a conjecture instead of giving a reason to support that. And so that's why we're not going to do a lot of inductive reasoning. We're going to do a lot of deductive reasoning, which is going to include reasons. All right. So we use inductive reasoning to make new discoveries and generalizations. Then a proof or an explanation is sought. So inductive reasoning is the first step in discovering new mathematical facts. So we begin by looking at it, making a generalization, but then we also have to do the hard work of doing a proof. And that gets us to deductive reasoning, and this is going to be a lot of the focus on Unit 2, is just beginning to build our understanding and our competency with that. So deductive reasoning is used to prove conjectures. That's the process of showing certain statements follow logically from agreed assumptions and proven facts. So here's where our definitions are going to really start to come into play. It's not that inductive reasoning isn't important, but we have to be able to kind of back that up. So your assignment for this is going to be one similar to the kind of questions you looked at here in this notes of making some observations, making conjectures, looking for counterexamples, okay? But understand that it's not going to be the primary emphasis of what we do throughout the course of this year. We're going to work toward deductive reasoning. So it has its place, but it's not the whole thing. All right, and I think we're done there. Great job. Good luck. Please ask any questions that you have to me. All right, thanks.